So our task here is to find the equation of this sine graph. Now it could be a cos graph, could be a negative sine, negative cos, but we'll make it a positive sine graph, and we know that the equation is going to be y equals a sine b bracket x minus c plus d, and we've got to find out a, b, c and d. We know that a is going to be the maximum minus the minimum divided by 2, and d is going to be the max plus the minimum divided by 2. So the next thing we need to do is find out where these maximum minimum lie. So we've got a maximum up here. Do it in red so we can see what's going on. And that point there, because of what we've counted, each of these is 60 to between 60 and 90 is going to be 75 on the x and negative 1 on the y. This is negative 1 here, and the minimum down here is going to be halfway between 120 and 150, which is 135, and the value there is negative 5. So we've got a maximum value of negative 1 and a minimum value of negative 5. We put that into the formula. We get negative 1 minus negative 5, max minus the min, divided by 2, and that's 4 over 2, which equals 2. So the amplitude is going to be 2, and we'll see how that's true in a minute. Over here, the d value is going to be negative 1, the max, plus the minimum, negative 5 over 2, which is negative 6 over 2, which is negative 3. So we've worked out values for A and D, and we'll come back to D in a minute, but A is the amplitude, perfect. Now to work out B, we need the period. So we can go to another maximum here, and we can work out the period quite easily. We know that that point there, halfway between 180 and 210, is going to be 195, and again it's going to be negative 1 as the y value. So the period will go from 75 to 195. That distance, the next distance. So it's from here all the way to here, sorry, to there. That is going to be the length of one period. Subtract 195 minus 75, we get 120. And we know that period equals 360 over B. So B will be 360 over the period. The period's 120, and therefore B will equal 3. Now to find the C value, we need to go to this negative 3 point. We know that negative 3 is here. This is going to be the axis of revolution or rotation for this sine graph. It goes right through the middle. It's not really an axis of symmetry because the top doesn't equal the bottom. But this value now is the C value. Why is it that value? It's because that's the first place that the sine graph starts. And the sine graph starts at 0 and goes up to a maximum. So that's the first time our sine graph starts. So that will be the C value. What is that value? Well, it's that point there, halfway between 30 and 60. So C is 45. And now you've got all four values. So the final answer is y equals 2. Sine B is 3. X minus C, X minus 45. And then the whole thing has been shifted down 3. And there's your answer there. Interesting enough, the amplitude A is this distance here. A is the distance from the line of rotation up to the maximum, and obviously down to the minimum as well. So the amplitude is the displacement away from the line of rotation. So we start off with our y equals a sine bx minus c, b bracket x minus c plus d. And we're going to get in there and find a few points. So we know that this minimum point here looks like it's the point halfway between 60 and 90. I think we've done that already. 75 degrees, comma 0. And the maximum up there is halfway between 150 and 180. That looks like it's 165. And the maximum point up here is 6. So we know that A is max minus min, 6 minus 0 over 2, which equals 3. D is max plus min, so 6 plus 0 over 2, which equals 3. So we've got A and D both equal 3. We know that B period equals 360 over B. So we need to go and find the period. This minimum here is going to be halfway between 240 and 270 is 255, comma 0. So therefore the period is going to be this length here, and 255 minus 75 is 180. So B equals 360 over 180. Bless you. Thank you. Which equals 2. Sorry about that, kids. And B equals 2. To find the C value, we go back to our D point. And D is positive 3, so we draw the line of rotation. And we're looking for the first time that sine starts its full revolution, which is there. That's the sine graph starting. So C will be this distance here, and therefore C will be 120. So your final answer is y equals 3 sine. B is 2, bracket x minus 120 degrees, plus D plus 3. So the data on the right there are the temperatures for St. Catherine's. You've got the average per month, so the high temperature per month and the low temperature per month, and in centigrade and Fahrenheit. So what we do is we choose any set of data, we'll take the highs, and we're going to put them onto a chart. So we know the months are going to go down the bottom here, and the 12 months, we just need to partition off 12 parts. Now this graph's going to be fairly rough and ready, but it should give you an idea of what's going on here. Now we know that the temperature, the highs go from 0 up to about 27. So we can do, we could do 10, 20, 30. And that's what I mean about being a little rough and ready, because we're not going to have the total degree of accuracy here that we need. So we're going to plot these points and see where we go from there. So we know that January is 0, so that's a big 0 on January. February is 1, so it's going to be just a little bit above. March is 5, that's going to be halfway there. April is 12, so just a little bit more than 10 there. May is 19, so just a little bit under 20 there. June is 24, so about there. July is 27, so you get the idea what we're doing here. August 26, a little bit low. September 22, so now we're coming down again. October 15, that's an easy one, that's on the axis. November is 8 there, and December is 3. And what you see is that if we were to now put these points in a line, we end up with a sine curve. Now granted, it's only really a half sine curve. Well, it's a full sine curve, because now when you get round to January, it starts repeating again. And that's what we've got to work on. So if we go on the idea of y equals a sine b bracket x minus c over x minus c and then plus d. We're trying to find some maximum min here, so we've got a minimum point here we think is what we'll call is 1, 0. And the maximum point is going to be in July, which I think is month 7. 2, 3, 4, 5, 6, 7 up there. So that is the point 7, and July was 27. So we've got a minimum and a maximum. As soon as we've got that, we're good to go. Because we know that A is going to be max minus min. So we know that 27 is the max, the minimum is 0, and divide by 2, and we get the answer 13.5. And D is max plus min, so 27 plus 0 divided by 2 is the same thing, 13.5. We get lucky here in St. Catherine's, having A and D both the same. Now B, the period. We know this from minimum to maximum is half a period, so 7 minus 1 will be half the period, which is 6. So the full period will be 12, which makes complete sense because this is a 12-month series. I mean, the weather is a 12-month cycle. And that's what happens. That's why it keeps repeating. So we've got 360 over B, and we know that B is 12. So period is 12, so it's 360 divided by 12, which equals 30 degrees. So we've got the value for B. We find 13.5 on the graph. Again, we're going to have some inaccuracy here. So 13.5 is about here, and that splits the graph in half. The axis of rotation. And we know that C is going to be this distance here. Now we can make a guess. It looks like it's going to be here. So this is 1, 2, 3, 4, and that's 5 there. So it looks like this point might be 4.25. Now it is a guess, and we'll go with 4.25 because it just helps our cause. If we look at the graph here, 13.5 lies in between 12 and 19. Now April is the 4th month and May is the 5th, so 4.25 is not a bad guesstimate at all. So our final answer is 13.5. Sine B is 30, bracket x minus 4.25 plus 13.5. Bit cramped for space here, sorry about that. Like that. Okay. Now, how does that help us? Well, what it does, it helps now people try and come up with a model for the temperature, for the high temperatures in St. Catherine's, which is quite interesting. And of course, what we could do now is do the same thing for the low temperatures and see if it's any different. So that's what I want you to do right now in class. Do a model for y equals a sine b bracket x minus c plus d for the low temperatures. And do exactly as I did just now. Draw a graph, come up with the model, find the maximum minimum. It will always work in 12 cycles. 12-month cycles, that's the way weather works. Okay. And once you've done that, now I want you to find a city that's near to your heart. So it could be across the other side of the world. Any city in the world will find data for it. So you're looking for, Google the monthly average air temperature in a particular city, and it could be anywhere you're interested in. Okay, and that's going to be the rest of class. And you're going to come up with a model that looks like y equals a sine b bracket x minus c plus d. All right, good luck, thanks.